In this video, a numerical that was asked in the GATE exam during 2020 is solved. The problem statement is given here. You can read, and a figure to solve this numerical is also shown. The first step in solving a numerical is to write the data given. Atmospheric pressure is given as 100 kPa. Initial pressure of air, denoted by the symbol P1, is given as 105 kPa. So this air is at a pressure of 105 kPa. Area of the piston, denoted by the symbol A suffix B, is given as 300 centimeters square. The spring constant, this is a spring. The spring constant, denoted by the symbol K, is given as 12.5 Newton per millimeter. Now, look for the quantity we need to calculate, that is, to find. We need to find work interaction, which is represented by the symbol W suffix T. That is the total work done. Now it's time to look for the solution. The work done WT is equal to W1 plus W2. What is this W1 and W2? The movement of the piston due to the addition of heat Q is divided into two steps, that is W1 and W2. In the first step, the piston moves freely for a length of 8 centimeters, and after that the piston moves another 8 centimeter, compressing a spring. So this is the second step, which is equal to W2. That means the work done during the second step, that means while compressing the spring. This two-step process is plotted in a PV diagram. So during the first step, since the piston moves freely, the pressure remains constant. That means P1 is equal to P2 is equal to P. In the second step, as the movement of the piston compresses the spring exerts a force which varies linearly. Therefore, the total force against which the piston moves S, the air pressure P, and the pressure offered by the spring. P2 to P3 is linear because it is given in the problem statement as linear spring. Just now, we discussed movement of piston is divided into two stages or two steps. In the first step, there is no spring pressure and hence the piston expands freely. The expansion is animated here. For the first 8 centimeter movement of the piston, no pressure is exerted by the spring on the piston. The plot in PV diagram for the movement in the first stage is given like this. P1 is equal to P2, which is equal to P. The pressure is constant because free expansion. And hence it is a constant pressure process. Work done during the stage 1 or step 1 is equal to product of pressure and change in volume. Of course, it is a displacement work. Displacement work is given by integral PdV. Pressure is constant. Therefore, dV upon integration after substituting the limit gives us V2 minus V1. What is the value of V2 and V1? They are not given directly, but V2 minus V1 is equal to the displacement of the piston, and the displacement of the piston is equal to area of the piston multiplied by the distance it gets displaced. Area of piston given as 300 centimeter square, which is equal to 0.03 meter square, and the distance through which the piston is displaced is equal to 8 centimeters. L equal to 8 centimeter, which is equal to 0.08 meters. Now, V2 minus V1 is equal to 0.03 multiplied by 0.08. Of course, here there is a product or multiplication symbol. The product of these two things gives us 0.0024 meter square. Once V2 minus V1 is known, we can calculate the work done during stage 1 or step 1 by substituting the value of pressure and V2 minus V1. Pressure is 105 and V2 minus V1 is here. This 10 power 3 is to convert kPa into pascals. That gives work done is equal to 252 joules. And this is the work done during stage 1 or step 1. The work done during the second step, that is when the piston moves, compressing the spring, is calculated in this slide. In stage 2, that is step 2, the piston moves against spring force. So the remaining 8 centimeter piston will compress the spring during its course of movement. Spring displacement is equal to 8 centimeter, that is converted into meters. And if you look at this, the piston has moved, gets stopped at this location. During this movement, the spring is compressed. The distance moved by the piston is equal to 8 centimeters. Spring force is equal to a and the displacement of the spring. Substituting the value of K and X, we can find spring force. Spring is exerting a force of 1000 newtons, which is equal to 1 kilonewton over the piston. That means the upward movement of the piston is resisted by a force of 1 kilonewton offered by the spring. Therefore, the pressure acting on the piston due to this spring force, denoted by the symbol P suffix S. Suffix S stands for spring, is equal to force by the spring divided by area of the piston. Substitution of force and the area of the piston gives us spring pressure. When the piston begins its movement in the second stage, pressure is equal to the pressure of air. But when the piston reaches the stop, in addition to the air pressure, a spring pressure of 33.33 kilopascal also acts. This spring pressure is not constant, it varies linearly because the spring force F varies as per the displacement. Therefore, the total pressure at the end of piston movement That means when it reaches the stop is equal to 105 plus 33.33 is equal to 138.33 kilopascal. Also, during the movement of the piston in the second stage, the volume change V2 minus V1 is equal to displacement of the piston, which we already calculated as 0.0024 meter square, because the distance 8 centimeter is same for both the stages and the area of the piston is also same. I will try to plot the second stage movement in a PV diagram, and this red color line represents the pressure offered by the piston, not by the piston, by the spring over the piston. At the beginning, it is equal to 105 kPa. At the end, it is equal to 138.33. And we know work done during this process is equal to the area under the curve in a PV diagram. This geometry is a trapezium. Therefore, work done during second step or second stage is equal to pressure plus the total pressure. That means the pressure here and the total pressure divided by 2 multiplied by change in volume when the piston moves against the spring. Upon substitution, we get work done during step 2 or stage 2 is equal to 0.291 kilojoules, that is equal to 292 joules. Now, the total work done WT is equal to 252 plus 292 is equal to 544 joules. 544 joules is the final answer for this problem.